Everybody, welcome back to the LearnAPCalc series here at LearnAP. In this video we're going to talk about the limit definition of an integral. So we'll go over definite integrals. We'll cover those a little more in the next video, but just a very brief flyby of those. And then we'll talk about those as the limit of a Riemann sum. As usual guys, if you've got a comment or question, be sure to leave a comment, or you can also ask in the live streams we do every Sunday from 4 to 5 p.m. Eastern, where we answer any questions of yours about AP Calc. Alright, so other than that, we'll get started. Alright, so let's talk about definite integrals. In our last video, I said, if we have a curve like this, how do we estimate, say, this area right here? And we went over different Riemann sums, trapezoids, etc. But definite integrals provide a precise answer for things like this. So let's say we had y equals x squared. And I want to find my area from 0 to 1. I can do the trapezoidal rule, I can do left Riemann sums, right, midpoint, what have you. But to get a precise estimate, I can actually just take the integral, the definite integral, from 0 to 1, and this will give me the exact area under the curve. We'll talk about how to evaluate something like this and why this is the case later, but just know that that's what this represents. Alright, so as you might have guessed, a definite integral can also be written as the limit of a Riemann sum. So let's take our formula for the right Riemann sum. Now, a question. If we keep a constant delta x sub n, meaning that if we had, say, two intervals here, that my delta x is going to stay constant. What would happen as we shrunk delta x sub n and had more sort of subintervals? So going from, say, this estimate to this estimate. Well, we're going to get more precise. So if we can get delta x infinitely small, we'd have an exact estimate. And so this is what a definite integral does, but we can also express this as a limit. So the definite integral from a to b of f of x simply represents this. That represents this exact area. Well, that would also equal a Riemann sum with an infinite amount of subintervals, which is this. Now, this looks sort of a little weird, but it can actually be written in a way that can be solved. So, take for example, this one right here. Write this as a limit. So let's see what we can do. Lim as n goes to infinity and then f of x sub k. So x sub k plus 1 to the 4th times delta x. Alright, so as mentioned, delta x equals b minus a over n. So I can rewrite this like so. But before I do that, so let's write that, b minus a. So this is b, this is a. So b minus a is 2 all over n. And now I want to write x sub k in this format. So a is -1 plus k times delta x, which as we just found is 2 over n, plus 1. If I simplify the inside, and this should be the sum from k equals 1 to n, and then this is the limit as n goes to infinity. Okay, so now we've written this definite integral as a limit. There's ways to solve this, but you're not going to be asked to do that on the AP test. You need certain formulas to actually figure that out. Alright, so that brings me to today's challenge problem. Write the following limit as a definite integral. So write this as a definite integral. The solution, as usual, is on our website, learn-ap.com, and I'll also put a direct link in the description. If you guys found this video helpful, please like, be sure to subscribe for future content. You can like us on Facebook and follow us on Twitter for updates about our new videos and live streams, which we do every Sunday from 4 to 5 p.m. Eastern, where we answer any of your questions about AP Calc. Links to that stuff will also be in the description. Leave a comment if you're still confused about anything, or also any other comments on the video in general. Other than that, I want to thank you guys for watching, and I will see you in the next video.